global warming, or the rise in average global temperature, is caused by the increase of greenhouse gases in the atmosphere. Some of the solutions known to the general public are driving less, using solar or wind energy, and eating a more plant-based diet. But these aren't real solutions. The current infrastructure of human society requires the use of combustion to generate power for transportation, factories, industrial plants, and more. Unfortunately, this releases carbon dioxide, a greenhouse gas that contributes to trapping heat in the atmosphere. It isn't realistic for all of those things to suddenly switch to sustainable forms of energy, so ultimately, the solution to global warming is to stop the carbon dioxide and other greenhouse gases from reaching the atmosphere. One of the ways scientists look to do this is through the use of metal organic frameworks, or MOFs for short. MOFs form a pattern of metal clusters connected to organic ligands, creating a crystalline network. They have many applications because of their high surface area, adjustable pore size, and stability in varying environments. An important application of MOFs is the uptake of carbon dioxide gas. This works through the adsorption of the carbon dioxide, made possible by the MOF's high surface area. The MOF kind of acts as a sponge for the carbon dioxide. One MOF that has a high uptake is called DPTZ-CuTIF6, which is also known as the Barbie MOF for its pink color. The Barbie MOF is synthesized by combining the metal ions copper nitrate hemipentahydrate and ammonium hexafluorotitanate with the organic ligand DPTZ in the presence of deionized water and methanol, employing the solvothermal method of synthesis. Although it performs well adsorbing carbon dioxide under dry conditions, this performance is significantly impaired within humid conditions. Due to the often humid conditions associated with industrial environments, the implementation of this MOF would require an optimized synthesis to improve carbon uptake. In order to do this, I've been working in the Materials Discovery Laboratory at Oregon State University to produce polymer MOF beads. By synthesizing a spherical bead made up of the hydrophobic polymer polyvinylidene fluoride, or PVDF, combined with the MOF, we will ideally improve the water-resistant characteristics of the MOF and thus improve uptake. The highly hydrophobic polymer works to improve the stability and performance of the MOF in a wet environment. Using this MOF and polymer bead in industrial environments could prevent carbon dioxide gas from leaving the factories or plants and stop it from ever entering the atmosphere, mitigating the effects of global warming without demanding the immediate change of our society's infrastructure. Using MOFs for carbon capture is a super creative solution, and I find them really interesting. Thank you.